All right, here's a test. And you see, there's two sides to it. And I've got a lot of the stuff you'd expect to see on there. Some mechanisms, a chromatography thing you're going to have to do, obviously. And, of course, some naming and a gas chromatogram. Pretty much what you'd expect. A lot of the stuff that's on here. Let's go over the mechanisms first. But I want to start actually with something different. I want to start with a mechanism. Can you tell which? Obviously, I give you them, and I will do this. There's a couple places, like on the back here. I'm going to give you the mechanism. I'll ask you questions about it. And there's other places I'm going to give you the full reaction, and I want you to tell me what mechanism will he go by. So let's take a look at those possibilities first. Okay? This is kind of important because there's at least 4 different places where you'll have to do this. All right? So say I gave you this mechanism, or I'm sorry, this overall reaction, whatever it might be. Okay? If I do this plus, I'm sorry. What mechanism does that have to be?
Free radical.
Free radical halogenation. Okay, good. You figure that out. What if I give you this guy? What does that guy have to be?
Electrophilic.
Electrophilic addition, right? It's the only one that's an addition reaction. The other ones are all going to be substitutions. Now, this is the tough one. If I give you the next guy, here, you got to tell which one is it. It's not really that tough because you know by now, I hope, although it is confusing. I can give you a primary one where I've got, plus water, say, or I can give you a tertiary one plus, say, water. And it doesn't have to, it could be anything, plus anything where they're going to replace each other. And you're going to get, or, okay, so your question for this one, is nucleophilic substitution, but which one is it? All right, and why? This guy is going to go by what mechanism? This is where you have to kind of think. And honest to God, I'm not making this up. Having taught this for 20-some years, when I see one of these, I have to think about it because I don't memorize my way through something. I look at this guy, he's primary. All right, so I know it's going to go in how many steps is that mechanism going to happen in? It's only going to happen in all one step, right? Then I think to myself, okay, the guy that happens all in one step is which one of the 2 mechanisms? SN2, because basically both guys are involved in the slow step. So that's how you think about it. You don't memorize your way through it. A lot of you guys just like to memorize. And that's why you find this stuff so hard. And that's also why you'll do it exactly backwards and get every one of them. If you get one wrong, you're going to get them all wrong. You know what I'm saying? So it's best to understand this guy's tertiary. Why does this guy want to go? Why will he go through the SN1 mechanism? 2 reasons. 1, too much crap around it, too much steric hindrance to get that guy to come in there at the same time. And the second reason, he can lose that guy. It's a leaving group. He will lose that guy. And he can still form a carbonium ion and disperse the charge better because of all the alpha groups. He can't. That's a primary carbon. It won't be able to do that. All right, so that's one kind of question. It's going to show up at least 2 or 3 different places, maybe 4 on the test. All right, I was just looking at the test and saw that. Now let's go back to these. Let's go over these and do each of the steps. Each mechanism, and I will give you the mechanism written out sometimes. On the back side, I did that a couple of places. This is a 2-step mechanism. What do you think this guy is? SN1, SN2, electrophilic addition, or free radical? SN1. Oh, idiot.
What the?
That's what we're watching next. We'll be watching that in The Fallacies of Love. That's a video on it. So, anyway, where was it? SN what?
1.
SN1, because it's a 2-step mechanism. Does that mean every 2-step mechanism is SN1? No, I don't have up here electrophilic addition. How many steps are electrophilic addition? 2 steps. There are 2 steps in electrophilic addition, right? That's not SN1. It's electrophilic addition. And you'll know that because that has a double bond in it. And you're adding across the double bond, not substituting 2 guys, okay? What is this guy right here? SN what? 2. Can't be SN1 as well. All right, it's happening in 1 step, therefore he's SN2. Both guys are involved in the slow step or the rate determining step. This is free radical halogenation. I think everybody would have gotten that. Now, next question. Identify all the electrophiles. What's attracted to electrons here? Let's see. I have that OH attracted to is that electrophile? Is that an electrophile there? No. But if I were to have an electrophile, I don't think it's even shown here. It's not. The electrophile would be where the H comes together with the Br. Okay, but that's not even shown in this reaction, so you can't really identify the electrophile of this reaction. All right, here, is there an electrophile? Where? I mean, I guess technically you could say, since this guy's the positive, slightly positive carbon here, but no, there's not really an this is not an electrophilic addition. And this is free radical halogenation. It doesn't have any electrophiles either. What?
Can the large molecules be electrified?
Well, I just said that. I mean, technically, this guy here is got a slight. Did I already have that first? This has got a slight positive. He's pulling a little bit more negative here. So this carbon is electrophilic. He's electrophilic. All right. But as far as when I ask you a question like that on the test, I think it's going to be obvious. I'll probably ask you a question about electrophiles that will apply to a specific question, and it will probably be electrophilic addition, or where in this step you actually can see an electrophile reacting. Now, nucleophiles in this one are pretty much easy. All right, for the nucleophile, he's going to be attracted to something positive, and that will be the OH in this group, right? And here, the nucleophile is the OH again, right? There are no nucleophiles in the free radical halogenation. Carbocations. Do we have a carbocation here? Yes, that's that whole thing is a carbocation or a carbonium ion. Do I have a carbonium ion here? No. Do I have one here? No. All right, free radicals. Well, I'm obviously not going to have you circle every one of them, but the free radicals you could have written down would have been the chlorine free radical wherever he exists, the methyl free radical wherever he exists. Okay, those are your two major free radicals. If I said to circle them in a step, then you would circle them in a particular step. All right, but wherever they exist with one unpaired electron, that's a free radical. Yeah. Question? What?
Yeah, when you said, like, remember before how we, like, circled or boxed everything, and you said don't box every single one?
Right.
For the OH, which OHs would
Well, again, that's a good question. See that? I had a good question. I would want you to circle, OH exists. OH, if you look at the overall reaction, there's an OH here, there's an OH here, there's an OH everywhere. You want to circle where the OH is actually acting as the nucleophile. So in this step, it will be right here, okay? And again, I might show it a little bit differently. And here, I really wouldn't care. As this one's forming, it could either be here or here, but I certainly wouldn't do it there. It's already on there, okay? All right? So it's where it's acting like the nucleophile. Finally, the chain propagating steps. If I wanted to identify them, that would be pretty easy. There are guys where I start with a free radical, and I regenerate a free radical. So both this one and that one are chain propagating steps. Agreed? All right. Chain, what is this one? Chain initiating step. And these guys over here? Terminating because they end with no free radical and they started with a free radical. Okay? Great. Now let's go back to that other page. This one here. Okay? And then we'll do that last one over there, and we won't have a whole lot of time after that probably. Now look, you guys actually got to do this lab. The other class saw at least a demo, and they saw the results of it from you guys anyway. This is called a what? Separatory funnel, right. And if you remember in the lab we did, we use it to what's that process called? Extraction. Okay. And the names and locations of the two layers. It's an amazing thing. Honestly, God, I get this as an answer. I probably got it on the worksheets, I think. And we'll get it on a test. So what's this layer? And they'll say the bottom layer. Yes, it's the bottom layer. Thanks. What is it? Is it the organic layer when we did the lab, or was it the aqueous layer? This was, see, I got both of them. It's the organic layer. We drew off the bottom. The chloroform was in the bottom. And what was in there? That's where the caffeine was, right? Yeah.
Is it always in that order?
No, but I will ask you in the lab we did, in both examples that we did, both my demo and the lab we did, where was the caffeine, what layer was in the bottom? It would be the chloroform or organic, because it's heavier, it's the more dense of the two. And this would be the aqueous layer. That's the name of the two layers too. Don't say the top layer and the bottom layer, okay? Let's look at this guy over here. Who's going to be the lightest compound here? Methanol, because it comes out the first in the gas chromatogram. And the one in greatest abundance would be the highest one, or the largest one. Isopropanol would be the one in greatest abundance, okay? If we had to do this, by the way, I did ask this question a little bit more difficultly on the test, because I didn't have a ruler to put on it. So basically, you have to know where to measure from. You measure from here, the starting point, to here for your RF equals ds over df, right? Your distance of the front, the solvent front, is from here to there, right? Not from the bottom of the paper, but from here to there. Got it? That's important. And then the DS would be, if it was for what spot? The red spot, it'd be from here to there. Okay? You could never get a number higher than 1, right? Because it'll be this number. Let's just say he's 4. Looks like 4 centimeters. No, he's going to be 3 because you have to subtract that 3. And over 4 would be about 0.75, right? For that guy. Approximately. All right, good enough. Let's go and name this guy over here. All right? That guy on the board. Did you all finish this one? Or no? I can see you didn't. We'll give you a few seconds to try that guy because you really need to try him. Use that chart, okay? Get that chart out. You're going to get a chart just like this on the test, okay? Do that guy right now, and then I'll go over it. You know what we could do? We'll have time to go over at least some of your worksheet. Let's go over the part about the mixtures. Because that was the part that I didn't do at all in the review anyway. And there is that on the test. We'll do that after we do this. So finish that up first. All right, let's do this one quickly because we don't have a whole lot of time. Hopefully you got most of this done. I told you I'm not going to care about alphabetical order here, okay? So let's kind of ignore that, and let's just go from left to right. Now, the one thing you do have to keep in mind, the one guy that's not going to be able to just go left to right, all right, is going to be if there's a double or a triple bond, because that has to be in the name of, like, for example, butene. It has to be, the EN should be right there. You know what I'm saying? So that's where it should be, at the butenoic acid, for example. In this case, who takes precedence? Who's the highest precedence on that chart? No, it is, but is there a carboxylic acid on here?
No.
No. So the highest precedence on here would be the aldehyde. So I got to start from this side. He's going to be the lowest number possible, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So there's 9 of them total. The last thing I'm going to write is going to be non-something. But anyway, let's start with 1, 2, 3, 4, 5, 6, 7. At the 7th one, I've got this guy. What do we call that guy? A tert-butyl. So I've got 7 tert-butyl. Okay. 6, what would that be? If he's an OH, if he's the highest priority, it'd be OL as an ending, you know, propanol, butanol. But because he's not the highest priority, I call him what? 6-hydroxy. Okay. 5, is that the 5th one? 1, 2, 3, 4, 5 fluoro. 4, what do we call that guy? A ketone in the middle there. Yeah, 4-oxo. 1, 2 amino. Let's not forget, we have to put that aldehyde at the end. It'll end in Al, but let's not forget about our triple bond that was in there. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. 8 non-now. That sounds like a made-up name.
Y. Should be Y.
No.
It's a triple.
Right, it's a triple one. Sorry, not 9L. Sorry, it's a triple one. YL. YNAL.
Wow.
Not 9L. Not 9L. Wow, that's pretty bad. But that's pretty good. Now, if you could do that, there'll be at least 1 or 2 of those in the test as well. You have to answer. Of course. All right. Like a problem like this, I'll tell you what we're going to do. All right, a problem like that, depending on how, it probably won't be quite as long as this, especially if I have more than one. If I have only one, it might be this long. But so it'll be worth like 1, 2, 3, 4, 5, 6, maybe 7 points because it's got 7 things to name in it, right? All right, real quickly on your worksheets. All right, let's look at that worksheet that you guys have. It's this one here, right?
Yeah.
And on the front side, or the back side, I guess, for you guys, it says which one of these things are you going to use? Simple, distillation, fractional, chromatography, or filtration. Substance 1 and 4. Okay, for substance 1 and 4, you've got a nonpolar solid, and you've got and water, basically, polar water. If it's nonpolar solid and water, they're not going to mix at all, are they? So an example of that would be something like, sand and water. It's not going to mix. So what could you simply do to separate those? Filtration, absolutely. Now you've got substance 3 and 4, where you've got a polar liquid, all right, with a boiling point of 65, and you got a polar water with a boiling point of 100. What could you do there? Fractional distillation, because you've got 2 liquids, all right, with different enough boiling points that we could probably separate them that way. 1 and 5, I've got a nonpolar solid. It's insoluble in water. And I've got a slightly nonpolar solid that's insoluble in water. What might I be able to use there? Yeah. All right. So remember, chromatography takes into account the difference in solubility. So if I dissolve those both in a solvent, one of them is going to be attracted more to the paper. For example, if I'm using paper chromatography or whatever. And then 2 and 4, I've got a polar solid that's going to dissolve in water. Right? Soluble in water. And then I've got water I dissolve it into. All right? But it's a solid, right? So what could I use there? That's like putting salt in water or sugar in water. How could I separate salt? Just simple distillation. Okay? All right, good enough. I'm looking around on this worksheet, see if there's anything else I can, you'll definitely see on a test.
Are we supposed to name these on Monday? Remember?
What's that?
Name the compounds.
Yeah, well, I never put any extras on the board. I was going to we didn't have time because we have a shortened period today.
So we're just not going to do it.
So, we just did one. There's one. I would have put 4 short ones on the board. I put 1 long one on the board instead.
So
And you're not handing them in anyway. So it's not a problem.
We're not handing them